Okay. So first let me go to the PPT ones. Is it PPT is visible to everyone? Is it visible, Amma? The first point, you should understand about what you mean by the neural network, and you should also understand about the
Yes, sir.
difference between machine learning to the neural network. That is very important point. Here, the neural network is basically computational model that is inspired by the way biological neuron structure, human brain structure, because we can able to store the information biologically. We can able to extract the future of any image, any topic, even for the text, speech, communication with other people, and we can extract the feature of a fan, we can extract the feature of a wall, door, everything. So the name it is given for a door as a door itself. In Telugu, we can say it is it's like a talpulu, or in Telugu it is any meaning. If there is something like a wall, in Telugu we can call them as a goda. Means we are learning in a particular format. The format we are memorizing, we are remembering. Our neurons are connected in such a way, and they pass the information to one neuron to another neuron. Like that, we are create with a one trained model with a memory. So that is the basic structure. The artificial neural network cannot mimic complete 100% of a human brain, but we are trying to make it is a mimic like a neural structure. So that is a process. Actually, neurons are connected in this way. It's completely different genre compared to the machine learning. It's a complete different genre. In machine learning, we have a learning process, but there is no a memorization process. There is no passing of a new feature information to one layer to another layer. Such kind of structures are not there in machine learning. But here, neural networks, look, we are following that. Now, this is a one neuron. Every neuron will connect it to the nearly 30 plus thousands of other neurons. One neuron has a connection with 30 plus 30,000 plus other neurons. It's not a simple point. You are a one person. How much of social media communication, how many people of social communications are there, including your relatives, your friends, your classmates, you are up to the 10th intermediate, your faculty, all together, it's not even greater than the 10,000 people. You know the faces of 10,000. They know the face of you. Up to it is a maximum count. 10,000 is a maximum count. If you are a politician, it may be a lakhs. It may be a crores. I am not talking. It's a normal person. In similar way, here you can understand a neuron. It is receiving the data from other neurons. X1, X2, X3, X up to XNR will become a input. They are passing to this neuron. How the inputs are creating, we are not talking about how the inputs are creating. Some inputs are created, that may be from your eyes, that may be from your skin, that may be from your ears. Somewhere the input is created, that inputs are will become input to this neuron. Now this neuron will do the process like a recalling the information or analyze the your input. Finally again it is passing to the other neuron also will receive the same information like that. Finally there are so many high layers are there like that. Finally all neuron communications will conclude with a one output. The output mean will become a y1 to the y up to ym, because when I looking at a particular area, the area is not only with a one tree, it may be with several kind of vehicles are there, human beings are moving, there is a one building, all together I can see or cover with my eyes can cover a area. At the same time my brain immediately extracting the feature of different kind of images and shapes, bodies, vehicles, everything. It's ultimately complete can able to perform in a fraction of seconds. So that is nothing but the number of outputs are generating m, it is a count of m, inputs are count of n, multiple inputs I can able to take. Based on that one I can able to find out the few number of outputs, or it may be greater than, less than. I'm not talking about the how many inputs you are taking or how many outputs are you are providing. So, but that is a neuron numerical structure. In a similar way, what actually a neuron? A single element. It's a neuron is a single element. Consider an artificial neural network. A basic unit is a neuron. Basic nothing but I could say this circle is a one neuron. Only one circle. These all are inputs. Now, how many here? These all are inputs. how many neurons are connected, so many layers are connected. In similar way, there are some inputs are created all together passing to the one neuron. But whenever you come to the structure, this is a one neuron, neuron number two. Sorry, these are the neuron. This is the input, neuron number one, neuron number two, and these are also input. Variable one, variable two, variable two. All these are x1, x2, x3, x4, like that input. Now neuron number one, two, three, four, five, six, like that. In the next layer, the neurons are will become only three. In the last layer, only one neuron is there. Like that, a neuron receives the data from input. The input may be multiple input or single input. Whereas coming to the in the input layer, you are passing only single input. But whereas coming to this neuron, multiple inputs are getting from all other neurons. Like that, neuron receive the multiple inputs. The structure will receive the multiple inputs. Now, whenever the structure is receiving the multiple number of inputs, every input is a x consider. According to this diagram, according to this corresponding neuron, and all these neurons are considered as a x values. X1 transmitted to this neuron, X2 transmitted the data, X3 transmitting, X4 also transmitting. I could say from here the sketch I will use. Okay. Now let us consider this is a one neuron. I want to explain about this neuron. Okay, now this is become a input number one. Okay, so consider this is a some x value, some x1 value. Now next neuron also sending the value to here. Now it is considered as some x2. Okay, now there is a one more neuron also transmitting. All inputs are transmitting, and input nothing but according to the perspective of this neuron, these all are will become input. Whenever you come to this neuron, this first one is become a input. Now it in this perspective it is become a x1, like that. We should consider whenever you are processing a one neuron, coming towards the data to a neuron is a input, and passing out from the neuron is become a output. Okay, now like that, one neuron here, one neuron receives the multiple number of inputs, and from here also. So now all together become input to this neuron. In similar way, other neurons also receiving the input from the multiple inputs. Now in such a way, just we are elaborating with a one, only one. I would want to change the color also. Okay, now what is going to be happen here? There are one input is transmitting one input. Okay, whenever it is transmitting the one input, random weight will be add random weight. So that is become a W1. Whenever x2 will transmit into the neuron, the random weight will be add. Like that, weight is a inbuilt structural process. Weight is a inbuilt structural process in the neural network, because a small weight will be add from for every new input value whenever it is reaching, so that the value of the first input is become a that x1. Okay, x1 with what is the weight is become a w1. So this is the first input value. The second input value is become a the input value is a x2, but including weight it is become a x2 and w2 also. Like that, all neurons so all inputs are evaluated along with the input value with weight. Now at this point of neuron, sorry, where? Okay. Okay. At this point of this is a one neuron. Now neuron receives multiple inputs. Now it should be process something. I should listen the voice of every one student of a particular issue. I call you student number one and tell me about the issue, what happened in the class. I ask to the second student, I ask to the third student, I ask to the all 60 voices. I will listen about a one problem, and I should take a summarization result and a conclusion result from all 60 number of voice, 60 number of discussions. Similar way, all inputs are become input to the this one input, and it will implement this kind of function. Okay, here be nothing but a small bias. There is a small bias already. We discussed in the class what do you mean by the bias. So bias is also a random value. Will we create inbuilt? We are actually not adding in the code. If your data set is prepared not well, every data set has small bias. If efficient data may have a less bias, inefficient data may have a highest bias. There is a variance value. Like that bias, we are expecting some bias. I'm not 100% perfect in every area, every part, every character. Means when I love my father. but I cannot fulfill the 100% of his requirement because somewhere there may be a bias. Similarly, your data has some bias, so that we are adding bias also. By default, some value will be get add that bias. What do you mean by the bias? What do you mean by the bias? Example, there are some elements are there you want to classify. All your results are basically in a class. There are some exam conducted. The exam results are out of 10. Most of the students are getting 7, 8, 9, and 10. So these are the values 7, 8, 9, 7, 9, 10. All the students almost. But two students are getting value. Actually, we don't have a value like a 2, 3. Nobody get the 2, 3. But two persons are get, one person is 2, one more person is a 1. Out of 100, out of 100 values, see, out of 100 students, there are only two students have the values are like a 2 comma 3. The remaining 98 students are their values are between 7 to 10 only. Now, which is create a kind of variance, a large variance. It's nothing but a difference, a large difference. Actually, a running person, a long jump person want to able to jump from 2 meters. He is jumping position. He will take the jump from here, and obviously, his maximum length of the jump is here only. Maximum length. Hit the deadline. Nobody can jump after this one. This is our last bias. The values are, initially he has taken this step here. Second time, whenever he is jumping to here. Third time he is jumping to here. Fourth time he is here. And fifth time he is here. And fifth time he jumped to here. Okay. See, what is our final deadline? This is the point is deadline. Our deadline is this one. We cannot expect the more than, but the values are, and he whenever he take the value, the first jump here, second, third, fourth, like that. Now, so this difference is calculated as some bias here. First element to the our target, our deadline. Second element to the our deadline. Third element to the our deadline. Fourth element to the our deadline. So which created some bias because the data finally will convert into numerical value. I explained in the yesterday only. Whatever the data, it is a language data, it is image data, speech data, any data, video data will be converted finally into a numerical value. Whenever numerical they convert into numerical value, easily we can recognize the difference between the some target value, some most the bias target value to your input value. So that can able to identify. So that is generally called as a bias. Now see, the bias, normal bias is I is equal to 1 to n, means there are n inputs are there, and a neuron will process in such a way summation of all the values, and which produce the one output. Now this neuron release one output. Now this output is become input to the one more neuron. There is one more neuron will receive the data. This output will become input to the one more neuron. Before passing the information to another neuron, we are also including a max pooling process, a activation process. We are including because directly summation and perform this kind of function and blindly we should not pass the value. We should apply some other category, some other activation, some operations like activation, max pooling, like that. Okay. So now, finally I could say this is a one neuron structure. One neuron. The next one here I want to explain clearly. This is the input layer, initial neuron layer, and next one is a hidden layer. Next one is a one more layer. Then how many layers you want to create? Yes, you can create. You can create multiple layers. Finally, there is a one output layer. Output layer also may consisting of a multiple number of neurons. Depends upon number of classes. Okay, multiple number of neurons can able to create. Okay, now we could say it is output number 1, this is output number 2, this is output number 3, output number 4, like that. This is a basic neuron structure. But again, neuron structure, I already explained. Input node, no computation is done at the input layer. Here with, they just pass the information to the next layer. So they are called as an input layer. Generally, they are calling like a x1, x2, x3, like that. Okay, na? Mostly the operation is done. Our whatever we discuss, the operation will be done at the hidden layer. Hidden layer, a block of nodes is also called as a layer. Okay, na? Input node or input layer. Input layer cannot perform any operation because there is no prior input. It's just to simply pass the information by adding a weight. Now hidden layer, actually who will perform the data operation? Hidden layers are hidden nodes. In the hidden layer is where intermediate process computation is done by performing the computational, like that. Just before the slide we discussed about a computational function. So that process will be done and pass the information to the next hidden layer. So finally there is an output layer. Here we finally activation function that map the desired output. The desired output may be consisting of a multiple number of class, if at all, then multiple number of neurons will be released the output. Then connection and weight is very important. The network consisting of a connection, each connection transfer the output of a neuron, and with to the another neuron J, while it is transmitting, it is the connection will add a weight. But I already tell that some weight is adding whenever it is moving from here to here. So see here, now I am transmitting the data to here. Some weight will be add. Some weight will be add. That weight is calculated based on the based on this point. You can understand the network consists of a connection. Each connection transfer the output from I to J. While it is transmitting, it is also adding some weight, that is like that are evaluating like a W subscript of ij. And activation functions we need to add for every layer. That activation functions are basically define output. That node give the input and or set of inputs. A node define the output of that node given as input of set of inputs. Means I'm pushing one value, but the activation, my output should be activate to transfer to the multiple inputs. I want to go in a one car. What I should do? The car is able to carry 7 members. Is 7 members, for 7 members, everyone should sit in the car. I should drive. I should operate. I should add the fuel. I should create a generation of a energy. Like that, we are activating the car mechanism. We are make run the car on the road. So then the 7 people can able to travel. So that is actually car is there. Is car able to run? But we should create the activation function by switch on and burn the fuel, and it create the energy and able to travel to your destination. Similarly, output will create by a one neuron, but that is become input to the another neuron, and it is connected to the multiple neurons. So it create the activation function to transfer the data. Now there is a learning rule which model. So we will discuss this slide later. Then activation functions are basically there is a sigmoid activation functions are there that basically can able to operate for 0 to 1 maximum. It's very suitable for like binary classification. There is a fever is there or not, tumors are there or not, yes or no, I'm going to college or not. Only one answer. There is a binary classification we are using. And tan h is also an activation function. It mostly the value is become a -1 to the 1. And ReLU activation function is the best suitable for all models because almost the data sets are multi-classes. So that it's starting from 0 to infinity value. Okay. Now I think we will discuss that. Followed by this structure, you should understand. Finally, somewhere your data is a collection of, if there is an image, basically we are discussing, whenever you discuss about the CNN model, RNN model and ANN model, they have inbuilt neuron structure. Especially whenever you come to the CNN, it must be operate on image. Then if there are some image, ANN also a neural structure. Their input is become a direct numerical values. If there is an image is a collection of pixel. Now if there is a one box, you can see this one. 0 for first pixel, next one more 0, one more 0, like that, one, like that. We have a different values. I want to choose only the part of this one. I want to choose this part. This part. How many? What is the dimension? 3 by 3 dimension. It's 3 by 3 dimension. That is become a one piece. Two piece. Second, I want to choose a one more 3 by 3 structure. One more 3 by 3 structure. This is become a second piece. Like that. It is extracting in a particular dimension 3 by 3, 3 by 3, 3 by 3. Several 3 by 3s are creating. Several 3 by 3s are created. Okay, na? And their dimension will be reduced by the max pooling. Now 3 by 3 dimension will reduce it to the 2 by 2 because we are reducing 2 by 2 like that. So now what happened here? like the max pooling, we can use a min pooling, max pooling, average pooling, like any kind of function we can able to use. After we dividing into the layers are again applied with a max pooling function to reduce the dimension, then followed by we have a several all so many layers are there. Finally, at the end, to perform the classification, we had to apply the dense layer. Now, first you should remember one point: these convolution layers are used to extract the features. Means this is a image data, na? This is a complete image data. There we don't have any numerical value. If you convert your image into numerical value, the value will become very large. Because see, a image is a 2 MB. I'm taking very simple data. A image has a 2 MB. 2 MB nothing but how many bits are there? How many bits are there? Megabytes. Means it's a 20 lakh bits are there. 20 lakh bits. And like that in data set, like that hundreds of thousands of images are there. Then see, you understand how many binary codes are there. For one image, to classify one image, there are 20 lakh bytes are there. It is not so easy. First we need to extract the feature from image. So for that we are using the convolution neural network along with the max pooling. Then followed by, you finally we will get some numerical value set from convolution neural. And on this numerical value set, we are applying the general classification by using the dense layer structure. Now, dense layer structure will apply the classification. Whereas, whenever you go to the SVM random forest, for that model, we are uploading directly the feature extracted data from the CSV file. But image is not a direct value of feature extracted data. It is a image. It is a raw data that should be converted into numerical value like a CSV. So, like that, this is the basic structure. Now, I want to explain about the ANN model. Very easy. My ANN model is very easy. Very easy. Because in ANN is not suitable for the image classification. It is very suitable for only the numerical classification, because we don't have a convolution layers in artificial neural network. We have only the dense layer structure. So like that, I'm uploading some data. Want to take a very simple data. Green plant house growth, something. Now green plant house data as added. Now just before type, just I want to run the code directly. Already I prepared the code. So now if we know that importing of pandas, NumPy, all these all are common, because I don't need to explain about what is the purpose of NumPy, TensorFlow, all those things I don't need to explain. And copy this path, and paste over here. That path we need to set. The variable name is a D. So run. So now this data connected to our code platform. And after connecting, what is I want to show data is very simple. It is a CSV file only. This is CSV file. You can see it is a normal CSV file, because ANN cannot classify the image data. It should be need a feature extracted data directly. It's same like a SVM and so on. But numerical structure can create more good classification result than normal machine learning algorithm. So now we want to see how many rows are there in that, how many rows are there, what is the shape of the data. There are 30,000 rows are there, and 14 number of classes are there. Classes nothing but 14 number of columns are there. Now along with that, I want to see the data corresponding columns. I want to see the columns. Yes, we can see we have a random, yeah, some values. It is a planned growth nothing but the relevant rows are there, total 14 rows. The last one is a class target, maybe it may be a target. Okay, then followed by we want to see about we want to define what is your target class, target column. We are defining directly, because already it is the ready-made data as in the column format. So we are created it as a class, as a the final class is a one target variable data. Okay, we set the target. Then after we have to check meanwhile we want to drop some columns. We want to drop some columns, because there is a one column like a numerical value we can observe. SA, all are numerical values. And one more, yeah, random also some numerical value. So non-numerical value, I could see it is a non-numerical values. For the X value, we are dropping that drop because class is allocated for Y, so we should drop. And random also we are dropping because it's not much importance in this data set, so we dropped that. The remaining values are being printed. For normally, whenever you are classifying a numerical data, we should also verify how is there any null column. Is there any null column? We should verify. We should verify is there any null column in the X. No, no, almost all are have their own value, something value. Now we are splitting the data. See, very easy. NN is very easy. That all the things are just we are verifying. They are not important. We are splitting. I think no need to explain why we are how we are splitting. Everybody knows that how we are splitting. Then train. We are dividing into 13, no, 30. What is the size? Test size is 30%. Then train size, how much of train size? Remaining part is become a train size. According to 30,000, train shape is become a 21,000 rows. So that generally, it's not a matter to we see all the things. But whenever you're writing a theory, we have to explain there are 20,000, 21,000 of samples are allocated for training purpose, testing purpose, remaining 9,000 for the testing purpose. Like that, if you want to write, first you derive them and you see. Followed by uh, followed by let us allocate and process the x and y values properly. I'm writing unnecessary lines actually. Already this line completed. This line is completed. This is your label column, your target column. Then encode the label, but encode it the class into a like 0, 1 format, true or false format, 1, 0, 1, 2, 3, like that. Convert into a label coder. Okay. So for that, first we are applying label encoder function. Encode the class label to integer because it must be converted into 0, 1, 2, 3, 4, like that. You know the column names are there. They are string format. They should be converted into some 0, 1, 2, 3, and so on like that. Then the Y encoder must be fit with a Y train data. Whenever it is training, the training per samples are there na, from all columns. They should be encoded to. They should be allocated to this variable, Y encoded variable. Okay. Then get number of unique classes. Unique classes to the are calling unique classes nothing but some rows are maybe repeated. So now we should not to be considered into our data like that. These lines are not much importance, but one hot encoder is very important line. This is very important. One hot encoder should be convert your data into the format I already explained about yesterday. They should be converted into like that 0, 1, 0, 0, like that. In case of there are three classes are there of three fruits like a banana, apple, and pineapple. Three fruits are there. Banana, if there is a existing of banana will become one. Remaining classes value will become a 0, 0. If there is a existing of apple, then banana 0. Apple is become one. Pineapple will become 0. So this format will be created. It's the example format I'm explained. So this is become a one hot encoded format. Okay, one hard encoded format. Then after we are confirming the shape, just we are printing. I'm writing some other extra lines to understand. That's it. They are much not important in our class. The next, we are also loading the data for X value also. Scalar, standardized scalar we are applying. It is one function for the under numerical value. Whenever you are processing, we should implement this standardized scalar operation. And same fit to transformer Y train. Here also fit to transform for the X. These are the normal functions. Okay, but for X we are applying the is we are applying the standardized scalar. For a y, we are applying for y, we are applying label encoder like that. Okay. Then followed by now apply the ANN model. ANN as only the dense layer, because already we should add the we should add a data. The data should be already feature extracted data. We should add ANN. It is a ANN model. It's much better than other machine learning classes. Sometimes it is become much better than other machine learning models. Okay, so that we are using artificial neural network model, which can able to process a transferring of memory. Now the input size is 64. Input dimension is a 12. Like that we have taken input dimension. Something activation function is a ReLU activation function. Okay, now the next layer is become a 16. Input layer is 64, then next layer is a 6, then next layer is a 8, then next layer is 6. You can take in different also, but at the same time, we should also see the accuracy. If you take a irrelevant or different neuron structure, sometimes you cannot get a proper accuracy. So accordingly, we have to plan the layer structures. Okay, now they have, I just, the sequential nothing but it should be creating a communication from one layer to the another layer in a order, in a sequence order. It is passing from one layer to another layer. So that is under a sequential function. Under this sequential function, we have created a four number of dense layers. Dense layer. The last dense layer is performing as a softmax activation. Above one are a ReLU activation functions. Then all together they are loaded into the model variable. Okay, na? Then this model variable is compared with ADAM optimizer, and we are evaluating the categorical loss, and we want to evaluate the metric of accuracy. So this is for training, creating a model only. Model compilation completed. Then after, this is up to a model and compilation completed. Then after, you train the model. Now after creating a model, train the model. Model fit x train model. This model variable dot fit x train by 1 hot, because already y value should be generated as a 1 hot encoded formatted data. It is not for x, but it should be a 1 hot encoded data for y. So these two are will become input. Total number of epochs are actually 50. I want to reduce it to the something like a 15. Uh, verbose is a parameter that you will understand. Theoretically, there is a lot of discussion we need for every variable. What is their purpose? Say not a platform to explain everything. Whenever you come to the college, I will take a separate class to make you understand every variable and their purpose, perspective, and use of them. And it is not much importance in its corresponding code. After that, after training, we should also perform the testing. So immediately we have a test results. Somewhere we have a execute test. These are the execute test operations. Okay. So this is a simple code for ANN. I think first these below lines are common for SVM. All the models, these are common. I want to make you understand only the structure of ANN. See, very simple. But in the background, the structure is in a neuron connection structure. Okay. So I'm running. I don't know it is executing or not. It started executing. It is running. I run for 15 epochs. I think I not initiated the batch. Batch also we can able to initiate. Something actually one nothing, but it is almost 100% accuracy it is giving. So this is all about ANN model. Now tomorrow I will explain some other model, and you start your own practice first of all. Okay. I'm ending the session. You start your own practice, Amma. You take the help of ChatGPT. If you don't understand any statement, you can gather the information from any YouTube video or else any other repositories. But finally, you should learn about the first model and the inner description, inner the function, use of the function, variables, and like that. Okay. So I'm ending the session.